This tutorial is about the elements of an ecosystem for development of application programming interfaces, APIs. API services obtain revenue based on access by client apps written by other developers. But first, those developers need to find or discover that the API exists, perhaps from galleries of available APIs such as API Suguru. It helps to have a comparison of results from static quality scans evaluating machine-readable interface specs of the API. There are several competing API specification formats, such as RAML, Waddle, and Swagger, but Swagger seems to be the most popular at this time. Discussion and evaluation of APIs can be more focused when they revolve around community agreement of a specific set of rules driving quality scans. Documentation about the APIs help not only for the APIs to be discovered from the public galleries, but also for developers to more quickly appreciate the intricacies of that API. What's even better than reading documentation is to interact live with a sample demonstration app so developers and potential users can really grasp the value of the services exposed. Then developers will be more enticed to get API keys client apps need to provide when accessing API services. Having enough sample data is important, so test automation scripts have the test coverage needed to make sure that all features really work and work quickly, even under load. A mock server doesn't provide all the logic and data from a real server, but some developers use them while they build their clients because they provide a stable endpoint running locally while off the network. All this is what makes up a full API ecosystem today. It takes effort to create docs, demo, test, and mock server code. That is why many have begun writing automated generation of such code. But ideally, the logic used to generate this code would be based on both the interface specification and wisdom culled from analysis of the metadata, gleaned from patterns and data over time, and analysis of history, previously only used for billing. More sophisticated variation of data values in generated code is now the frontier. Such data include values and statistics from both historical points in time and projections plus predictions of values expected in the future. With apps of enterprise scope and complexity, manual coding of the client and server code base by human developers can seem repetitive and be error-prone, therefore taking more time and be more expensive than what could be. So instead of manually defining interface specs, they can now be generated from the codebase by marking up server code with comments recognizable by a parser such as Deoxygen. All this cuts time to market because changes to server code can now be quickly reflected in the docs to client demo code, mock server code test code, and benchmark run results.